Hi again, it's Mrs. Goodboo here. We're going to look a little more at the relationships between sets of numbers right now. So any type of relationship that happens between two sets of numbers is called a relation. And there's a very specific type of relation that we like to talk about that's called a function. Now, they have some things in common, but a function is more specific than a relation. So if we talk about sets of numbers and how they work together, we'll talk about, let's say, a bouquet of flowers. So we know that if we sell one bouquet of flowers, we make $5. And if we sell two bouquets of flowers, we'll make $10. There's a couple ways we can look at those numbers. We can call the 1 and the 2, the amount of things we sell, our input. And if that's our input, then the amount of money we make out of that is called our output. Now, we know that there's new terms we're going to use, and we're going to call those our x's and our y's. And the reason we talk about x's and y's is because they help us graph numbers to show relationships. Now, what makes a function special is that for every x, there's only one y. So 1 only goes with 5, and 2 goes with 10. That doesn't necessarily happen with a relation. In a relation, you can have multiple things that go with something else, but in a function, every x only has one y. The reason this is important is that when we finally put this on a graph, it's going to give us a specific type of graph that's going to be really important later. So if we make this graph that we've just kind of started here, our input's the number of bouquets we sell. So the number of flowers we sell is going to go on the x-axis. Do you see right here where it says x? This line that goes across is our x-axis. This vertical one is our y-axis. And our y-axis here is going to represent how much money we made selling flowers. So that one flower or one bunch of flowers is going to make us $5. So that 1 and that 5 are going to work together to create a coordinate. Now, a coordinate it always starts with a bracket, and we always list our x first. So in this case, our x is 1 because we sold one bouquet of flowers. Then we put a comma, and we list our y, which in this case is going to be 5. So our x is always listed first, and then a comma and our y. And we put brackets around that to show that it's a coordinate. Now we can go on our graph and we can plot that. And the way we're going to do that is we're going to go look at our x value first. So it's telling me x is 1. So I'm going to come to the center of the graph, which is called the origin, and I'm going to go on the x-axis over to the 1. From there, I'm going to see what my y is, and my y was 5. So I'm going to go over to 1 and up to 5. And then I'm going to plot a point there, my coordinate on 1, 5. For my next number I talked about, I know that if I sell 2 bouquets of flowers, then I'm going to get $10. So that would be represented with a coordinate of 2, 10, because the 2 is my input, or my x, and the 10 is my output, or the y. So I write that as a coordinate as 2, 10. To plot that point, I'm going to come back over here to my graph. I'm going to again start in the center at 0, and I'm going to go over to 2 on the x, because that's listed first, and then I'm going to go up to the 10 where my y is. Oh, sorry, I meant to make that in red. Now, this isn't on here, on my chart specifically, but what if I sold no flowers? How much money would I expect to make? I'd make no money. So it's also safe to say that I could plot another point at 0 0 right here. Because if I sell no flowers, I will make no money. So if we look at this, we've got a couple things happening here. These are ordered pairs right here. These coordinates are called ordered pairs. I'll write that down for you. Ordered pairs. And they are listed as x, comma, y, and we call them coordinates. They tell us where to go on the graph. This table I drew right here is called a table of values. So our table of values, oops, I misspelled values. Our table of values leads us to find our ordered pairs, which are coordinates, and then we can plot those points on our graph. Now, the last thing we want to talk about is what exactly it looks like when we have a relation that is a function. So what does it look like when something is a function or is not a function? Now, on a graph, if something is a function, then the line or curve that will be created will pass what we call the vertical line test. And what that means is that you can take your pencil and put it anywhere on this curve, and if you lay it down vertically, and it will only go through one time. So, for example, is there anywhere on this graph that I can draw a vertical line that would pass through the red in more than one place? And there's not. So therefore, I know it is a function. Versus if I had a curve that looked like this, is there somewhere on here where I could draw a line and it would pass through the red in two places? Oh, look, right here. See? It's passing through my red curve twice. So therefore, this is not a function. Not a function because it fails the vertical line test. The other way to tell is if you look at a table of values, on the table of values, remember you have your x and your y. The x is always written on the left. If you've got x values, let's say are 1, 2, and 3, you can only have one y value for each x. So you can say that the y value with 1 is 5, and the y value with 2 is 7, and the y value with 3 is 9. This is a function because every x only has one y. It would look different if you had something like this. If you had that same 1, 2, and 3, but let's say this time your 1 could go with 5 or 7. This would make this not a function. So to recap, any set of numbers that have a relationship are going to be a relation, but specifically we call them a function when there's only one y to go with one x. And when you take your table of values with x's and y's, you can write them together as a coordinate point and plot them on your graph.